So for chapter number 8, we'll be looking at the binomial expansion. So first things first, to do that, we need to know something called Pascal's triangle. And I've written a part of Pascal's triangle here. So Pascal's triangle is useful because it allows us to expand brackets which have been raised to a certain power. So we know how to expand brackets, right? But if the power gets quite large, like maybe like 4, 5, 6, 7, then it just takes a very long time to expand. So we need a more simple, efficient, quicker way of doing it, and we can use the binomial expansion. So first things first, Pascal's triangle. It's made by just summing up the two numbers and they'll give you the number below. So as you can see here, if I sum up 1 and 1, I get 2 and that's the number below. If I sum up 1 and 2, I get 3. 2 and 1, I get 3 as well. So that's how we make Pascal's triangle. So if we were to continue it, then these two numbers summed up, 1 and 3 summed up will give me 4. 3 and 6 will give me 4. 3 and 1 will be 4, and then 1's are always on the outside. Same thing, if 1 is on the outside, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 5, and 1. Just do one more row. We have 1, 6, 15, 20, 15, 6, 1. So that's how Pascal's triangle is made. Okay? And so what it tells us is it allows us to know the coefficients of each term in our expansion. And so to know what row to choose, well, this row here is when n is 1, n being the power, right? So if we have something raised to a certain power of n, this row is n is 1, the second is n is 2, so n is 3, n is 4, n is 5, and so on, n is 6. So as long as you choose the right numbers as the coefficients, then you can expand any brackets. So let's take a look at an example. Let's say maybe we want to expand x plus y to the power of 4. Obviously, we can do that by just expanding each bracket separately, but we want to do it more efficiently. So first things first, we have to find out the terms first. So where we go about doing it is, imagine this is the first term here and it's the second term. So as we go along, the first terms decrease in power and the second terms increase in power. So what do we mean by that? So well, the first term x, the maximum power can be is the power of 4, right? Plus the second term, the first term will decrease in power, so it's now x cubed because you're minusing 1 to the power. And the second term, you increase the power, so y is 1. Plus the next term, so you decrease the first term, so x squared, the y1 will increase in power, so y squared, and so on and so on. So it'll be x times y cubed, and finally it'll just be y to the power of 4 as the last one here. So the first and last terms are just the terms which are raised to the maximum powers, and in between just decrease the powers, and you increase the powers as well for the second one. So now we've got these, as we said, now we have to find the coefficients. So this is raised to the power of 4. So the line are these values here. Okay, so these are the coefficients of the expression. So now you just plug each value inside. So the first term is times 1. The second value is 4, right? So you times 4 to this. The third one is 6. The fourth one is 4. The last one is 1. And now after you simplify it, this is the final expansion. So x to the power of 4 plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the power of 4. So as you can see, it's a much easier and quicker way of expanding a bracket which has been raised to a higher power. Let's just try another one. So let's say we have a minus 2b to the power of 5. Because first things first, we have to find the terms, right? So as I said, this initial term we decrease in power, and this latter term we increase in power as we go along. So the first term is the initial one of a to the power of 5 this time, this is raised to the power of 5, plus we now decrease in power, so a4, and then we keep going, so a3, a2, a1, okay? So that's the a terms. Now the second term here, this minus 2b, we now increase in the power. So starting off here, we have minus 2b, including the minus sign is important. This one now is minus 2b squared, minus 2b cubed, minus 2b to the power of 4, and the last term will be minus 2b to the power of 5 on its own. So that's how we find the initial terms. And now we choose the correct line. So it's n to the power of 5, so we choose the fifth row, so these values here, and we'll just plug it in. So we have 1, 5, 10, 10, 5, 1 as the coefficients of each term. And now it's just a matter of simplifying it. So we'll have a to the power of 5, this will be minus 10a to the power of 4b, this will be plus 40a cubed b squared minus 80a squared b cubed plus 80a b to the power 4, and then minus 32b to the power 5, like this. Okay, so as long as you make sure you cube the 2's as well, so as they increase in power, they get cubed as well. But as long as you find the right row, then you can expand just about anything, or any bracket rate to a certain power.